Hello, and welcome to the fourth FMSP Core Prerequisites video. These videos are designed to help you get ahead with independent study of the A2 core, ready to develop the skills in A2 Further Pure modules. This is what you should know already. Obviously the AS core, and a couple of topics that are covered in previous videos. But this video is slightly different from the others in that it assumes you or have already met the chain rule from the A2 core. This video is focusing on developing fluency, not about understanding the basic ideas, so do make sure that you have met the chain rule before you try to work through this video. It's a good idea to have all this material at hand before you start, so pause the recording now and go and get everything together. It's particularly important with this video that you have set aside sufficient time to tackle the questions as well as to watch the video so that you are getting the hang of doing these questions for yourself. This is about being able to do simple and standard examples quickly in your head so that you can reverse the process to integrate. This isn't covered till a later video. It's important to develop the skills this way round first. So here is a mental method, a way of thinking about this, which means you don't have to write so much down and you can focus on what's happening. I've got the function y equals x cubed plus 3x all to the power 5. Normally, when you're using a written method for the chain rule, you would write y equals u to the 5 and you'd write lots of things down. But when you're working in your head, it might be easier to give it a different name rather than a letter so that it's easier not to get confused. So I'm calling this expression in that brackets thing. So I've got y equals thing to the 5. And when I differentiate y with respect to thing, I get 5 thing to the 4. Now this is what you'd be expecting to think in your head. You wouldn't be writing this down because this isn't good maths. What I'm trying to do is to get you a method for doing this in your head. So using the chain rule, you'll then differentiate thing with respect to whatever variable we're working with, which is x. And that's what's in the bracket. That's 3x squared plus 3. So all of this is supposed to be in your head. So now let's actually look at what we get doing the whole lot in your head. dy by dx. So I've got thing to the 5, so that's 5 thing to the 4 multiplied by differentiate the thing 3x squared plus 3. I'll do a couple more examples before you have a go at doing one yourself. So, y is thing to the 4, so differentiating that, I get 4 thing, that's what's in the brackets, 2x squared minus 5x to the 3, multiplied by differentiate the thing, that's 4x minus 5. And another one. This is again, thing to the 4, so when I differentiate it, I get 4 thing to the 3, multiplied by differentiate the thing, which is sin x, to get cos x. Here's a nasty looking one, y equals e to the sin x, that's e to the thing. So if I differentiate e to the thing, I get e to the thing. And then I need to differentiate the thing, which is sin x, so multiply that by cos x. So you'd normally write that cos x e to the sin x. Now as you get used to doing this sort of question, you'll be organised enough to leave a bit of space in front of the e because you know you're going to need it to write the derivative of that power. So in fact, what I would normally do for this, I think, differentiating e to the sin x, differentiate e to the thing, I get e to the thing, differentiate the thing, write it in front, cos x, e to the sin x. That way I haven't had to do any working at all. I've been able to do it all in my head, just anticipating where I'm going to need to write things. One more example before we have some for you to have a go at. Y equals sine thing. That's your input there. So if I differentiate sine thing, I get cos thing. And then if I differentiate that, it's 4, and rather than writing times 4 at the end, I'm going to squash in a 4 in front. This is a fairly standard example, and it's almost worth learning as a standard example rather than using this method. If you're not feeling too confident, it might be worth rewinding the recording and going and listening to those examples again to make sure that you have got the hang of it. Otherwise, let's carry on with some examples for you to do. So, pause the video and try this one for yourself first, without doing any working, so not setting it out carefully as you've been taught, but trying to do it in your head. OK, if you've had a go, listen to this. I've got thing to the 4, so when I differentiate it, I get 4 thing to the 3 times 2. So 8 times 2x plus 1 cubed, so that's answer B. Again, pause the video and try this one. OK, if you've had a go, let's see what we've got. We do need to do a little bit of working here probably, because it's usually best and safest to rewrite as to the power 1. So now I've got thing to the power 1, and when I differentiate that, I get minus thing to the minus 2. And then I need to multiply by differentiate what's in the brackets, which is 2x, and I can squash that in there. Okay, you might want to rewrite that in a similar form to the original question. Really depends on what you've got to do with it next. And that, you can see, is answer D. Okay, pause the video again and have a go at this one. Okay, are you beginning to get the hang of it? I've got thing to the power 3, so that's 3 thing squared, and then I've got to differentiate what's inside. What's inside is x to the half, so if I differentiate that, I get a half x to the minus a half. So for the more complicated examples, you do have to do a little bit of extra work. Oh, I've missed out a minus sign, haven't I? Because it was minus x to the half, so that should be times minus a half x to the minus a half. Minus 3 2 root x 1 minus root x squared. It just goes to show that however good you think you are at these, it's always worth doing them twice just to make sure that you get the same answer both times. It's very easy to lose a minus sign here and there. So that's answer A. Okay, derivative of trig functions. Hopefully you've sorted this, otherwise you'll need to go back and look at a previous video. So pause the video and have a go at this one. Okay, I've got cos of thing, differentiate it, and I get minus sine of thing. Differentiate the thing, that'll give me 2, so that's minus 2 sine 2x. That's answer C. Note when you are differentiating trig functions that the input into the trig function always stays the same. That never changes. Okay, pause the video and have a go at this one. Right, so I've got log of sine x. So that's log of thing, and if I differentiate log of thing, I get 1 over thing. And then I need to differentiate the thing, so differentiate sine x and I get cos x, and that's cos x over sine x, which is cot x, which is answer C. Okay, this one is slightly different and you may not be quite so confident with these new trig functions, so I'll do this one as an example. Sec x is 1 over cos x. So what I'm doing here is I'm trying to differentiate cos x to the power minus 1. And I'm writing it like that so that we don't get mixed up with cos to the minus 1x, which on your calculator is arc cos x. So thing to the minus 1, differentiate it, and I get minus thing to the minus 2. Now differentiate what's in the bracket, the thing, differentiate cos x, and you get minus sin x. So the two minuses will cancel out, and I get sin x over cos squared x. That sin x over cos x is tan x, and I've got an extra 1 over cos x, which is sec x. This result is in the formula book, so you don't need to remember it, but they might ask you to show it, or you might need it as part of another question. You wouldn't be required to show any working. It will be perfectly okay to look it up unless it says show that. So here's a check question for you. You need to remember from the previous slide that when you differentiate sec x, you get tan x sec x. So now pause the video and try this one out. Okay, I've got sec thing, so that will be tan thing sec thing. Okay, noting that the inputs to both these functions here are the same as the input to my original function, in other words 2x. Then I need to differentiate the thing, differentiate 2x, and I get 2. So 2 tan 2x sec 2x, and that is answer B. Okay, now don't worry if you found the check questions hard to do in your head. What you need to do now is to go away and do loads and loads and loads of practice. You can redo exercises that you previously did with working, or you can ask your teacher for some more exercises. Remember, this mental method is needed later for A2 Further Pure. I hope you found this video useful. The next one completes the topic of trig functions and differentiation by developing fluency with the product and quotient rules, and by looking at implicit and parametric differentiation. Goodbye.